My name is Ido Erev, and I'm here in. I arrived here about 22 years ago. I came to the Technion, and I met Dani and Maya Val. The late Maya Val, was Dani's very careful assistant. And when I just arrived, I got my degree in psychology of decision making, and they were interested in related stuff, and they told me about two empirical results that they observed, and they challenged me to think about the relationship of these results to the psychology of decision making. One result was that many accidents, and this was based on careful analysis that Maya and Dani performed in accident analysis in factories in Israel, that many accidents occur because people appear to be over-creative. That is, they find really creative, reckless, they called it compensatory behavior. Look at this guy, how creative it is he's in fixing his car. Right, he found one road to put it and then the red box to make sure that the wheel will be fine, and another road. So it's really very highly creative. Of course, if he will move in the wrong way, something might happen. But this is one phenomenon. But there's another phenomenon that appears to be inconsistent. In contrast, as you already heard a lot about that here, the main problem in skill acquisition reflect insufficient creativity. People give up too early. They don't explore enough, and they don't find a better way to play the Space Fortress. And as Yaakov present, even hockey player, a half-professional hockey player, spend all their life as kids playing hockey. They don't explore enough strategies, don't look enough, and you have to come up with emphasis change training on other things to force them to be more creative while improving their skills. And let me give you a more extreme example. The guy here, probably the same guy there. I took it from the same source, from the internet. So he was so creative there when he was trying to fix his truck, but when he's trying to fix his marriage, he lost all creativity and he fell asleep. So there's really two problems here. So he's over-creative here, and here is not creative. Of course, maybe it's not the same person, I don't know for sure. So what's the explanation for that? It could be something about emotion, maybe. But knowing me, you probably don't think this is my explanation. So it took me 22 years to think about it until I met Kinneret. And then we come up with the following explanation. And I explain in a minute why it took us 22 years. Well, Kinneret was not born, maybe then. But why it took me 22 years to think about it. The explanation I favor now is that this apparent inconsistency between over-creativity there in the safety problem and insufficient creativity here is really could be resolved with the assertion that the same thing happening here. In both cases, people just underweight a rare event. They don't think enough about a rare event. So this guy, when he's so creative with a truck, he has a lot of experience picking up trucks and nothing happens. Most of the time you do this kind of thing, nothing bad happened. And this is generally for many work accidents. Most of the time you do the wrong thing, nothing happened. So if you underweight a rare event, you continue to do that. And here maybe in this, when you try to build your skills, you try new tricks, and most of the times they're not helping. And maybe in the case of these marriages, maybe he tries many times different things to fix his marriage, and it doesn't work. After a while, he gave up. So we argue that it's possible that these two phenomena that appear to be inconsistent are in fact the result of the same thing. That is, reliance tending to underweight a event. The reason why it took me so many years to think about this explanation is that this assertion that underweighting this underweighting of rare event explanation of the coexistence of reckless over creativity and insufficient creativity in skill acquisition appears to be inconsistent with basic decision-making research. One of the most important phenomena in basic decision-making research is that people overweight rare events. In particular, this is an explanation of the important phenomena that the same people buy insurance and lotteries. This is one of the most important violations of mainstream economic theory. Mainstream economic theory assumes that people are either risk averse or risk seekers. The fact that people buy both insurance, when they buy insurance, they behave as if they are risk averse, but when they buy lottery, they behave as if they are risk seekers. So the explanation for that, and this is one of the contributions of Kalman and Tversky classical paper, the explanation for that is that people exhibit oversensitivity to rare event. So they are overweight rare event. So this robust and important phenomena is inconsistent with the explanation I proposed in the previous slides. So much of my research in recent years is try to understand the coexistence, now the second order bias here. In order to try to clarify the contradicting reaction to rare events, we study simple choice problems, and these experiments I ran with Greg Barron and with many other people. Some of them are here. I guess with Iris Neveau was the first time I used this particular gambles. In this experiment, and Eldad described some of the experiments, the subject basically have to select between the two keys. Every time they select on this key, they get 0 for sure, and on this key, 90% of the time they win 1 shekel, and 10% chance to lose 10. When we run these experiments, we find two phenomena. First, when the subject rely on the description and first makes the first choice and have to rely on this outcome, they exhibit, they tend to prefer the 0 for sure. So they don't like the gamble. That is, this is replication of the Kahneman-Tversky result, that they are very careful. They worry about the rare event. In fact, they don't like the gamble, even if the loss is not 10, it's only 8, they still don't like the gamble. So when they decide based on the description, they exhibit overweighting of rare event. However, when the experiment is repeated 100 times, and after each trial they get feedback, experience moves them to prefer the gamble. So in the first 5 trials, they select the safe prospect about 60% of the time, but from trial 5 to trial 100, they tend to select the gamble 60% of the time and select the safe outcome only 40% of the time. Namely, experience trigger underweighting of rare event. They start the experiments worrying about the rare event, but with experience they learn to behave as if they believe that it won't happen to me. So basically what we are suggesting here is there is a difference between decision based on experience when you underweight a rare event, and when you make decision from description, then you overweight a rare event. We believe that this gap can be results of two phenomena. One phenomena well known in social psychology based on the words of Wagner, I guess, known as the white bear effect. Close your eyes for a minute and don't think about the white bear. This is really hard to do. And the idea is that when you try to do it, white bear come to mind. And the idea is that what happens at a bare presentation of a new stimuli, even if I would not show you white bear, just mentioning, attracts attention. And we think that something like that happened in the Kahneman-Tversky research. When you just present the gambles and you say you can lose 10, even if with small probabilities, this loss of 10 come to mind more than its weight based on the 10% probability. Okay, this is why we think people overweight a rare event when they first presented with a new stimuli. However, when people gain experience, what they tend to do is to rely on past experience in similar situations. So they think about the most similar situation to the current trial, and their tendency is to rely on a small sample of past experience. In particular, in the typical experiments, we see that the subject behave as if they rely on a sample of about 4. And if you rely only on a sample of about 4, rare events that happen 1 in 10 most of the time will not be in your sample. So you behave as if you underweight a rare event. Okay, we find similar results. This phenomena is very robust. We find similar behavior by honeybees. And we organized 2 international choice prediction competition on different gambles. And the winners in both competition were people who proposed models that imply reliance on small samples of past experience. In another experiment with Eldad, we found that we ran the same experiment, but this time we asked subject to plan in advance. We say we're going to play this gamble 100 times. You have to plan in advance how many times you want to select 0 for sure and how many times you want to play the risky gamble. the results reveal that when people can plan their behavior, they plan to go for the safe outcomes. They don't like the gamble. However, if we allow them, after they plan their decision, to change their behavior, they do change their behavior and move to select the risky gambles. That is, planning is similar to decision from description, and ongoing behavior is similar to decision from experience. So here is a partial summary. I tried to convince you that over-creativity that lead to reckless behavior and insufficient creativity that lead to in skill acquisition can be the product of underweighting of rare event. These biases emerge only when people rely on past experience and can be the product of reliance on small samples. The opposite bias, overweighting of rare events, emerges in decision from description and also when people plan their behavior. What I would like to do next, and this is also an effect of Danny, is to try to talk about the implication of that. That is, when I arrive here, I learned from Danny that it's good to do applied research. So I try to find a way to have something productive. This is a summary of research conducted with mostly Dotan Rudensky in the Center for Safety Research at the Technion. What we try to do is to think what's the implication of this phenomena I just described to you. What are implications for the enforcement of safety rules? And we reached to the conclusion that we think there are 4 conclusions that can be derived from that. First, enforcement is necessary. People violate safety rules even when they know that it's dangerous, even when you tell them the probabilities, and even when they plan not to violate them. So just giving the information is not enough. People plan to do the right thing but end up doing the wrong thing. So enforcement is necessary. Second, and this surprised, this is a project we conducted in 12 different factories, and this surprised the manager of these factories. This observation suggests the data I've presented suggests that when people plan their behavior, they actually plan to avoid risk. This suggests that when you tell workers in factories that you're going to try to enforce obeying safety rules, they're actually going to like it. So managers really did not believe that, but this is the case. When you come to workers and tell them, about this risk, we're going to now have an enforcement system to make sure you don't do that, they are happy that the management want to do it. A third point that, again, will surprise people, including Minister Silvan Shalom. Just 3 days ago, I read in the news that he suggested to have a punishment of 2 years in jail for each person that will carry a knife. I guess this was a good reason why he said that now. What we're suggesting that large punishment like that can be too large. Probability, because of course, to put each person that carry a knife in jail for 2 years, it's pretty costly. Of course, for court and also to put them in jail. And the probability cannot be very high. And what we are suggesting is that the probability of punishment is much more important than the magnitude, because people underweight a rare event. So if we're just going to give this punishment with small probability, they underweight the probability that they will be killed. And similar thing will happen with large punishment with small probability. And the fourth point is that when large punishment are too costly, as is typically the case, then gentle enforcement, small punishment, if you can provide them with high probability, can be more effective. So this research we done with 12 factories. Basically what we did, we came to the factories and took a baseline measurement for people using hand protection, that is glove, hearing protection, and eye protection. And we saw that the level of obeying the safety rule was about 60% on average of these 3 things. And then we basically collected the worker and gave them a talk similar to the talk that I gave you here, telling them that we know that most people want to obey safety rules, but sometimes it doesn't happen because they forget, they don't think. And we suggested that we're going to start a new enforcement system in which the supervisor will punish them for each one of these violations, but the punishment would be small. In fact, in some of the factory, we give them, each lottery get 100 lottery ticket for a weekend in Tiberius. And every time we gave many lotteries, so each lottery ticket was really worth only 10 cents, 10 agorot. And each time they violate safety rules, their supervisor will take them one lottery ticket. That was the only punishment, so it's not very large. And then we encourage supervisor to now every time a person does something wrong, to come to him and say, hey Moshe, you forgot to use your eye protection. I really worry about your eyesight. I have to give you now a small punishment. And because it's small, it will not annoy the worker. And this is the outcome. We started implementation here, and within a month, we got to about 90% safety level went up to about 90 to 100%. And this experiment was run for 3 years. And Dotan Rudensky is still working with some of this factory in his business. So this is one example of implication. In another project with Yoel Donchin here, we did something similar in hospital. We tried to encourage nurses and doctors to encourage each other to use gloves when they take blood. And we got very similar results. Here, even without punishment, just a reminder, which is unpleasant when you get a reminder from your peers, they first agree to remind each other. And once they do that, within a short period, proportion of using gloves went from 50% to 100%, not to 100%, to 90%, but the head of the hospital said that he got a letter from the logistic department saying, what happened? All the gloves disappears. Here are several related observations. First, Dov Zohar will talk tomorrow in this meeting about safety climate. One way to think about our result is an easy or cheap way to implement safety climate. Of course, safety climate have more stuff than that. Another observation, a related observation, that many enforcement systems have two Nash equilibrium. Nash is like Nash from the movie. In one equilibrium point, there's many violators. When there are many violators, think about cheating in exam. When everybody is moving their head and looking at people sitting next to them, the proctors or the professors cannot punish everybody. So the probability of punishment is very low, and typically could be, in fact, close to zero. And then cheating become an equilibrium. That is, equilibrium is a point that you do what is good for you and everybody do what is good for them, and no one is motivated to change. So if everybody in class cheat, no one is motivated to change. So this is a stable situation. This is an equilibrium. Everybody violates the rule. Similar thing, of course, happen in factories. However, there's another equilibrium. In the other equilibrium, when no one cheats, everybody focus on their work, no one moves their head, then the proctor and even a professor can see the first person who moves their head and ask them to move to the first row, and then no one is motivated to try to cheat, because once you try to do it, you're being punished immediately. So this is another equilibrium. And in fact, we implemented this idea in exams at the Technion. When we started that research, the rule at the Technion was that in the beginning of the exam, the proctor have to prepare a map of the class. And the idea of the map was that once you prepare a map, if the professor thinks that someone cheated, then he looks at the correlation. I'm doing something wrong here. So if the professor thinks that someone cheated, he can check the map. Now I'm 22 years here, and I've never looked at any of this map. I don't know if any other people look at this map. But what happened that in the beginning of the exam, for 15 minutes, the proctor were busy preparing their map. Once they were done preparing the map, everybody in the class it was a big party in the class, and we were already in the bad equilibrium. All that we proposed to the professor in the Technion is to delay the preparation of the map by 50 minutes and just look at the class. When the proctors and the professor look at the class, no one has motivation to move their head. And if they prepare the map later, nothing bad happens because you're already at a good equilibrium. In fact, what they decide to do in the Technion, I think, and is being done now, they prepare the map before they give the exams. This, of course, has the same effect. And we have recent research on that, and we found that, in fact, this reduces perception of cheating. Another question is how to reduce, for example, people using their horn or even traffic accident. And our argument here is that you can have large punishment for violators, and this is what the ministers want to do. However, much easier way to reduce traffic accident, just to make sure that every small violation will be punished, even by a small amount. So one idea is, and of course this technology has become available nowadays, you can put green boxes in cars that every time you do something silly, like taking a turn in 120 kilometers an hour, you will get a small punishment, maybe an increase of 10 shekels in your insurance for next year. So if it's really important to take this turn, you do it, but probably will not do it very often. And my hope is that maybe one day we use something like that to make sure that people, to reduce the tendency of Israelis to use their horn. So if every time you use your horn, it costs you 1 shekel, maybe use your horn less. A related observation is instruction in legal documents. Often we have to read instructions about safety or when we buy products. And if you are like me, many people never read this instruction. You just sign here, you sign there, and you continue. Now, when it's important for people to read, maybe you have to enforce it. And one way to do it is by having stuff like having quizzes about reading and stuff like that. So there are interesting legal implications. So these are implications for the tendency to underweight rare event and in safety and related stuff. I want now to talk about application in skill acquisition. So and of course you already heard a lot about that. The idea here that the current logic suggests that insufficient creativity in skill acquisition emerges when the common outcome of trying new strategies is disappointing. Reliance on small sample in this case lead people to give up too early. And this is our explanation, and Danny and I wrote about that. This is consistent with what you already heard here about emphasis change training. And this is the idea that it's difficult to play and look around, so people learn to stop looking around and just focus on the ball, for in the example of basketball, and in hockey as Yaakov presented. So we think that this is one of the reasons why emphasis change training and IntelliGym system works. Of course, there may be other reasons why it works, but this is one of the contributors. A related argument, a related phenomena, has come from Steve Jobs. In one of his last interview before he died, he was asked what kind of marketing research have you used to come up with an iPad? And he probably didn't hear Yaakov's story about Eiffel. That would be a good answer, but he gave a different answer. And he said, we didn't use any marketing research because we don't think that consumers know what they want. It's not their job to know what they want. So basically, we thought what we should do, and we did it. So the question is, why this works for them? Of course, they were genius, but why is that stupid to ask people what they want? One explanation for that, this is our attempt, this is also with Kinneret, our attempt to explain Steve Jobs' behavior is that when you ask people, what do you want to have in your applications, they want lots of things. And when you give them all the things that they want, it's become too complex, and they never, and they stop exploring because they try to, because once it's become too complex, if you try to explore, it doesn't work. That is, most attempt to learn how to operate a particular function fail. You have to practice more, but people give up too early, as we already heard, and for that reason it doesn't work. One evidence of support for that I heard from from people from Microsoft that say that before they come up with Windows 7, they ask people who use Windows, they did this marketing research, ask them what kind of new features you want to have in Windows 7. And they got a list of, I think, 400 items, and then they realized that 350 out of these new features already exist in the old version of Windows, and those users ignored it. And let me, my last example is something optimistic about marriage life. My wife is here, so I'm safe, I guess. So how can we help this person here who gave up on his fixing his marriage, although he's willing to risk his life in order to fix his truck? So one optimistic assumption is that, a marriage or any interaction, even between Israeli and Palestinians, is you have to select your strategy and the other side select their strategy. Think about it as a game. I'm simplified it. Says that you only have 9 strategies, each person in this interaction. Could be, as I say, not only marriage. And now you have some payoff. So if a person, this column player here, a row player here, select A and the column player, player B, if he select 1 and this guy select 1, both of them lose 9. The pair from the left is for player A, the player for the right is a player B. Now if they know the pair of matrix, it will be easier for them to realize that there is really good outcome there. The 7-7 is an equilibrium. If both of them select strategy 9, both of them will get 7 and no one will be motivated to change. So this is a good strategy. So if you present the matrix for these people, then they will converge to the good outcome. However, if you don't present the matrix, and in most interaction, definitely marriage life, you don't know exactly what will be the outcome of each action that you're going to take, then you have to learn from experience. Now what happens if you learn from experience in matrices like that? In this matrix, player A will soon learn, unless if both of them select 9 at the same time, both of them get 7 and then they live like in the happily ever after. So that will be nice. And we have Agadot on that, fair in that. This happens sometimes. But most likely, this person learns that if he selects 4, almost always he gets at least 2. He gets 2, or the worst case is -1. And if he selects anything else, most of the time he gets -9. And that person over there will learn that strategy 7 is the safest, because most of the time he gets 2, sometimes -2, but this is pretty good. So they're going to converge to this point here, which is also a Nash equilibrium. So this game has 2 Nash equilibrium. Now if you don't explore enough, you're going to stack in this. So you have this interaction with 2 players that could make 7, but end up losing money. So they are really in a bad equilibrium. And the idea here, that if you are in a situation like that, maybe some more exploration. So people tend up to give up too early. And for that reason, an emphasis change training can help this guy in this setting. And also to his wife. Although it seems that she at least tried to think how to improve things. Okay, so here's my summary. What I try to convince you is too much creativity in safety decision shorts our life. Inefficient creativity in skill acquisition eliminates much of the fun when we are still alive. One of the contributors to this problem is underweighting of rare events in decision from experience. This bias can be the product of reliance on small sample of past experience. Certain training and management rule, like emphasis change training and gentle rule enforcement, can reduce these risks. This is my story.